Welcome to this lecture on hypothesis testing, where we are going to look at how to statistically test a claim or a hypothesis. So basically, a statistical hypothesis is a statement or a claim about a population parameter. Note, it is a statement or a claim about a population parameter. It's not just a general statement or claim, but you've said something concerning a population parameter, and as a result of that, we need to use a pair of hypotheses in order to test the claim. So one of the pair will represent the claim, and the other will be its complement to see which one holds. So which one of these hypotheses fails, the other must. So when one of these hypotheses fails, the other must be true. So how do we go about stating the hypothesis? In this class, we are going to use the first, second, and third pairs. These are not the only pairs that exist, but in this course, we will stick to these ones. Here we have what is known as the null hypothesis, and here we have the alternate hypothesis. We always have the null and alternate. So in this case, we are sticking to the population parameter known as the mean. So here there is the claim that is not really the claim, the number that has been declared. For example, someone can say the population mean is greater than 10. So you can use this pair because here you have less than or equal, and here you have greater than. Here you have greater than or equal, less than, and here you have equal and not equal. So every time a statement is made that has to do with equal or not equal, you use this pair. If you hear less than or you hear greater than or equal, you use this pair. Greater than or you hear less than or equal, you use this pair. So that's how you choose your pair. It's based on a declaration that is made. So if someone declares that something is at least a certain amount, you know you are using this pair. At most, you are using this pair. Greater than, that's it. Less than, not equal or equal, that's it. You are using this pair. So it's very important to determine what pair. Once you've determined the pair, in other words, the null and the complement, you can move on to identify your claim. Now, the null hypothesis is always the one that has an equal statement attached to it. For example, your null hypothesis in this case has equal, your null has greater than or equal, your null has less than or equal. So your null hypothesis is always the first one. Then the complement to that null hypothesis is called the alternate hypothesis. Now let's take this example. It says a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. You can see the word that is used, is 61, is 61. So you are dealing with an equality. So normally your null hypothesis has to be, so it says the proportion. So you are not using mean in this case, proportion. The P has to be equal to 61, and the alternate hypothesis is going to be not equal. Once you've done that, you can now say, okay, this is the claim. The claim is this. It could have been a statement where there was a claim made that it is not equal to 61. You would still have used this pair of hypotheses. However, the claim would have been there. That is extremely important. Identify the pair and identify the claim. If you do not identify which of the two is your claim, you will get confused when you are doing your conclusions at the end of hypothesis test. Now, let's take another example. A car dealership announces that the mean time for an oil change is less than 15 minutes. Here you have a claim about a population parameter and it says it's less than 15 minutes. In this case, we are using the mean, so the average. When it says less than, you know that the pair you are using is the less than and the greater than or equal. So for your null hypothesis, you remember I said the null hypothesis must always have the word equal attached to. So in this case, we are using greater than or equal for your null hypothesis, and the alternate, you will use less than, based on the pairs I presented earlier. So this is what you have, and you can see the claim that was made has to do with less than. So this is your claim. Your claim is the alternate hypothesis. Let's take another example. A company advertises that the mean life of its furnaces is more than 18 years. So it's more than 18 years. So you will use the pair of mean less than or equal to 18 and greater than 18 for your alternate hypothesis. So here you go greater than 18, less than or equal, and this is your claim. So once you have that, you can now proceed. So generally you have about a 7-step process. At times I bring it down to 6 or even 5. So the first thing is to state the claim mathematically and verbally. So here you have your null and alternative hypothesis, okay? You first write your null and alternative hypothesis. Then you specify the level of significance. It's always given, maybe 0.1, 0.05. It is given, you don't need to imagine it. Then, if you want, you can draw the graph. When we're dealing with the normal distribution and especially the central limit theorem, we saw how to do these things. You don't need to do it. Now you need to calculate the test statistic. We saw how to do it. So the formula during the second test, you did a lot of calculation of this. So this should be straightforward when we look at the equation. And then you go to your table and extract the p-value and you arrive at your conclusion. Now this is the rule of thumb. If the p-value is less than or equal to the level of significance, remember I told you this level of significance is always given. If it's less than, you reject the null hypothesis. If it is not less than, or if it's greater than, you fail to reject the null hypothesis. You must always remember this rule because you will use it all the time. And of course, you need to write a statement. Now let's take an example. The first case is where we know sigma. When we know sigma, it means we'll be using the Z table. When we do not know sigma and the n value is less than 30, then we will use the student T table. In this case, where we know sigma or n is greater than or equal to 30, we will use the Z table. So let's remind ourselves of the equation. This is the equation we will be using, and this part is known as your standard error. But this is the equation we will be using for the Z. So we'll compute the Z score, then we will look for the p-value, and we will compare the p-value. Now the p-value is from our tables. We will compare that p-value to the level of significance. Okay, let's take this example. We've been told that it says the mean pit stop time is less than 13. So you see less than 13, it already indicates that for your null and alternative hypothesis, you should be using greater than and less, greater than or equal and less than. So less than 13 seconds. A random selection of 32, your n is 32. The sample mean is 12.9. and the standard deviation is 0.19. Here you have your level of significance it's using. Level of significance has been given, you can use it. So null and alternative hypothesis, level of significance has been given. Now you need to calculate the test statistic using the formula. This is your formula. When you plug everything in it, you end with that. If you now go to your table, you will be able to find the p-value. This is your p-value when you go to your table. So given that this is your z-score negative 2.98, if you go to your table, you'll find that the p-value is 0.0014. And then you now compare your p-value to your level of significance. We did say if your p-value is less than, here we can see that the p-value is greater than the level of significance. Now remember what we had earlier said. We had said when the p-value is less than the level of significance, reject. If the p-value is not less than, fail to reject the null hypothesis. So when we come to that example, remember this is the claim. So in this case, we have a case where your p-value, you can clearly see that your p-value in this case is less than the level of significance. So you reject the null hypothesis. Less than why? Because here you have 0, 0, 1, here you have only 0, 1. So you reject the null hypothesis. And if you reject the null hypothesis, it means you fail to reject the alternate hypothesis. So if you reject the null hypothesis, given that this is not your claim, it means you do not reject your claim. Okay, that's always how it goes. Your decision is based on the null hypothesis. If you reject the null hypothesis and the null hypothesis is your claim, so you reject the claim. If you fail to reject the null hypothesis and it is your claim, it means you support the claim. On the other hand, if you fail to reject the null, so whatever you do to the null hypothesis, after that you now look the consequence on which one is your claim. So generally use this statement for your conclusion. Here we are saying that at 1% level of significance, you have sufficient evidence to conclude that the mean peak time is 13 seconds. So you always use a typical statement. I will go over it again next class so that it becomes very clear. Let's play around with this one. Here it simply says, according to a study, blah, 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 the mean is 21,500. You randomly select, you say you think this information is incorrect. Now note it has said that the mean is, okay? There is this claim, the mean is. So you are dealing with what is normally called a two-tailed test. It says you randomly select 25, so your sample size is 25, and you find that the cause is 20, blah, blah, blah. Now the standard deviation, the population standard deviation is known. This is it. And it goes on to say, is there enough evidence to support your claim at an alpha? So this is your level of significance. So if you look at the null and alternative hypothesis, there you go. The level of significance is given. You compute your z-score. You now look for the p-value. You look for the p-value. This is the p-value you will get. And based on the p-value, you can now compare your p-value to the level of significance. You can see that the level of significance is less than your p-value in this case. Your p-value is greater than the level of significance. So in this case, you fail to reject the null hypothesis. Now remember, your claim you were thinking that this was your claim, because they had initially said it is, and you had said no, you don't think it holds. So they had made this claim. Yeah, this was actually the claim. They had made this claim, and you say you don't think it is, and then you wanted to find out. So given that you failed to reject the null hypothesis, that simply means you do not have, it says, there is not enough evidence to support the claim that the mean course of bariatrics is different from. So there is not enough evidence to reject the claim that was made. So we will look at the last case where, well, in these two examples, we've basically seen all what is there to be seen here. The only thing to be done is, what about the case where we do not know the standard deviation or the sample size is less than 30? In that case, we will use the student t distribution. Now, the tables for the student t distribution for the p-values, we've not seen that. So we will always use technology. Any example where you need to use the p-value, where you need to calculate the p-value for the student t distribution, we will always use Excel. So in this case, we have a Department of Motor Vehicle Office claims that the mean wait time is less than 4 minutes. So this is their claim, less than 4 minutes. So we know we are dealing with the null hypothesis of greater than or equal and the alternative hypothesis of less than 14 minutes. Now, the sample is 10, the sample mean is 13, standard deviation, the sample standard deviation is 0.5, level of significance is 0.1. We want to test it. Now, if you use technology to calculate, you will simply, so this is your null. Let me see. Okay, this calculator they use, it's trying. Now this is your p-value, and so this is your p-value from. So it's a t-test. The t-test or the student t-distribution gives you this p-value. So you have to compare this p-value to your level of significance of 0.1 that was given. And when this is your null, this is your alternative hypothesis, when you do the math, you will find that your p-value is greater than your level of significance, so you fail to reject your null hypothesis. So that is basically all there is to do. And I'll see you in class.